Hi, 7th grade Trailblazer. So I did a little video where I combined volcanoes and earthquakes into one, and it's only 16 slides, and it's 2 chapters. So I made it quick, so that we can get through this fairly easily. Alright, so what is a volcano? You guys know that lava comes out of it, but what really is it? And it's just a mountain that forms in Earth's crust when molten material, or magma, reaches the surface. So it's like the conduit or the pipeline for getting magma out through Earth's crust. And magma is just a mixture of rock-forming substances, gases, and water that live in the mantle. When magma reaches the surface, it's called lava. Alright, so how do volcanoes tie into plate tectonics? And mostly it's that volcanic belts form along the boundaries of Earth's plates. Usually happens at divergent plate boundaries, however it can happen at convergent plate boundaries. The Ring of Fire is one huge, major belt of volcanoes found in the Pacific Rim, and this is considered the Pacific Rim over here. So Pacific Rim reaches from the east coast of Australia, Asia, Japan, to the west coast of North and South America. Alright, so the first graphic on the top left shows that where volcanoes happen at divergent plate boundaries, okay? Those usually happen at mid-ocean ridges, so it's happening in the middle of the ocean, and that's where those Pacific Rim volcanoes really come into play. This is how, the Hawaiian Islands are formed. But sometimes we get volcanoes forming at convergent plate boundaries, and this is due to subduction, and subduction simply means where the ocean floor sinks beneath a deep ocean trench and back into the mantle. And the bottom graphic really shows how the ocean floor sinks beneath a deep ocean trench and back into the mantle, and that allows, because we've got that break, that allows that magma to come up from the mantle. Alright. Not all volcanoes, however, form along plate boundaries. Some form at hot spots in Earth's mantle. And a hot spot is just an area where material from deep within Earth's mantle rises through the crust and melts to form magma. This is pretty much what the Hawaiian Islands are from. So they're not really on plate boundaries, but the magma is able to come up in those places, and that's how those whole islands actually formed. All right. The anatomy of a volcano, it's got different parts and different names. The first one we'll talk about is a magma chamber. That's just the pocket of magma beneath the surface of the volcano. And the way that it gets up through the volcano is through the pipe, which is the long tube that extends from Earth's crust up through the top, and it connects the magma chamber to Earth's surface. So this would be the pipe. The vent is molten rock and gas leave through the opening. So the vent is the opening. Lava flow, a spread of lava that pours out of the vent. And the crater is a bowl-shaped area that may form at the top of a volcano around the central vent. So that's the anatomy of a volcano. Alright, we have 2 types of eruptions that can happen. One's a very quiet eruption. This happens when magma is really hot, but it's low in silica. So the magma is really thin and runny, and it flows easily, so it's quiet. So eruptions in Hawaii are very quiet. Explosive eruptions are different. This is when magma is really high in silica, making it thick and sticky. So if it's thick and sticky, that magma builds up in the volcano's pipe, and it plugs it up like a cork in a bottle. Well, that's going to increase pressure. As more and more magma gets in there, it's going to increase the pressure until it explodes. When it explodes, it's very loud, it's very disruptive. It also kicks a lot of ash into the air, and this happened a few years ago. I think in Greenland or Iceland, where there was a really bad explosive eruption, and it put so much volcanic ash in the air that it actually disrupted flights over Europe and northern Europe or Eurasia. So it actually traveled and was disruptive for quite a while. Alright, we got 3 different types of volcanoes, and I know you can't see the graphic really well, but it is color-coded and shows which ones. There are 3 types. The first one is active. This is one that's erupting or has shown signs that it may erupt in the near future. Those are ones we have to be careful about. Dormant ones, too, because they're sleeping, but we expect it to awaken in the future and become active. And then lastly, extinct volcanoes is one that we don't think are ever going to erupt again. Now there's different types of volcanoes. The first one is the cinder cone volcanoes, and that's the middle graphic. And this is magma with high silica, so it builds up in a steep cone-shaped hill. So if it's a high silica, that means it's usually going to be explosive volcanoes that are going to throw that ash out into the air. Then we have composite volcanoes. These are tall cone-shaped mountains in which layers of lava alternate with layers of ash. So if you look at the first graphic on the right, it shows those different layers and how they alternate. And we have shield volcano. This is lava that builds a giant, wide, gently sloping mountain. So this is what we really see in Hawaii. This is those really quiet eruptions. And lastly, I didn't have the graphic on here. Lava plateaus are just taller. They're not really mountains. They don't come in these cone or mountain-shaped things, and it's just there's like cracks that run along the crust where magma actually can run out of that crust. All right, so that was volcanoes. We're going to move on to earthquakes. So forces created by plate movements are examples of stress, and stress is actually a force that acts on a rock to change its shape or volume. So force is a mathematical calculation, and so force can build up. So over time, as we get more force, something's gonna give, and eventually that force is going to do something. So there's three types of stress that can occur. The first one is tension stress. This is where rock in the crust can be stretched so that it becomes thinner in the middle. If you imagine pulling like a piece of gum, you'd have a clump in one hand and a clump in the middle, but it would be really thin, or a clump on each end, but it would be really thin in the middle. And that's kind of like how tension stress is. So if you look at C, or this bottom left one in this diagram, that's tension. Compression is the opposite. That's one plate pushing against another, so it squeezes it together. So it like you're pushing the gum back toward each other, your fingers back toward each other, and the gum would kind of build up in the middle. And eventually that would just stress would cause it to break in that middle. Lastly, we have shearing, and that's stress that pulls a mass of rock in two opposite directions, causing the rock to break and slip apart or change shape. So we have three types of faults that can happen. And this is when stress builds up in a rock, the rock is going to eventually break, because we said stress is a force. So first one is a normal fault. The rock is pulled apart by tension in Earth's crust. The fault cuts through rock at an angle, so one block of rock sits over the other fault while the other block lies under it. So if you look at the graphic, it's the one on the far left, and it shows that one is taller than the other. We then have a reverse one, which is the same structure as the normal fault, but the blocks move in the opposite direction. And lastly, we have strike slip. So rocks on either side of the fault slip past each other sideways with little up and down motion. So normal and reverse, we do have up and down motion. Strike slip, more right next to each other, back and forth. So an earthquake is the shaking and trembling that results from those different types of fault movement. So when the stress gets too bad and the force comes out, it's going to produce an earthquake from one of these different types of faults. So the different types are the ones we would just say. So seismic waves, oops, I forgot to give you a picture here. Seismic waves are vibrations that are similar to sound waves, and they travel through Earth carrying energy released by an earthquake. And we use seismic waves to measure the earthquake. So just some things that we have to know. The focus is the area beneath the Earth's surface where rock that was under stress begins to break or move, and we know it's because of one of those three fault movements we talked about. The point on the surface directly above the focus is called the epicenter. So where did it start? What's the geographical location? Now we study different waves to help us understand about earthquakes. So P waves compress and expand. S waves, on the other hand, vibrate from side to side, and then surface waves move, or what we measure that actually happen on the surface. They move more slowly than P waves and S waves, but they can make the ground roll like ocean waves. So there's three different types of seismic waves, and reading those with something called a seismograph can really help us understand how impactful the earthquake can be, because that's it. We don't want it to be impactful, and if we can measure it, hopefully we can reduce some of the human impact it has. There's 3 different scales that we use. The first one is the modified Mercalli scale, and it just rates the amount of shaking from an earthquake. Now, the Richter scale is the one that you guys are probably the most familiar with, and it measures the magnitude or size of an earthquake. So this graphic actually shows what it looks like, and each level is 10 times stronger than the previous level. So 10 on the Richter scale is crazy. It's awful. Thankfully, that only happens like every 1,000 years or so. But we have small earthquakes that happen every minute of the day, and we barely happen. And the good news is that earthquakes generally happen in the ocean, so human impact isn't great, which is great. So you can look over that Richter scale and give you some more info. And the last one we use is the movement scale, and it just rates the total energy an earthquake releases. So scientists usually use all 3 in concert. Concert means together. So they use all 3 scales in concert to really describe the earthquake. So I have one video for you guys, and you are off the hook for a while. Oops.
The year was 1816. Europe and North America had just been through a devastating series of wars, and a slow recovery seemed to be underway, but nature had other plans. After 2 years of poor harvests, the spring brought heavy rains and cold, flooding the rivers and causing crop failures from the British Isles to Switzerland, while odd-colored snow fell in Italy and Hungary. Famine, food riots, and disease epidemics ensued. Meanwhile, New England was blanketed by a strange fog that would not disperse, as the ground remained frozen well into June. In what came to be known as the Year Without a Summer, some thought the apocalypse had begun, a mood captured in Lord Byron's poem, Darkness. I had a dream, which was not all a dream. The bright sun was extinguished, and the stars did wander darkling in the eternal space, rayless and pathless, and the icy earth swung blind and blackening in the moonless air. Morn came and brought no day. They had no way of knowing that the real source of their misfortunes had occurred a year ago, thousands of miles away. The 1815 eruption of Mount Tambora on the Indonesian island of Sumbawa was what is known as a supervolcano, characterized by a volume of erupted material many times greater than that of ordinary volcanoes. And while the popular image of volcanic destruction is molten rock engulfing the surrounding land, far greater devastation is caused by what remains in the air. Volcanic ash dispersed by wind can blanket the sky for days, while toxic gases such as sulfur dioxide react in the stratosphere, blocking out solar radiation and drastically cooling the atmosphere below. The resulting volcanic winter, along with other effects such as acid rain, can affect multiple continents, disrupting natural cycles and annihilating the plant life on which other organisms, including humans, depend. Releasing nearly 160 cubic kilometers of rock, ash, and gas, the Mount Tambora eruption was the largest in recorded history, causing as many as 90,000 deaths. But previous eruptions have been even more deadly. The 1600 eruption of Peru's Huayna Putina is likely to have triggered the Russian famine that killed nearly 2 million, while more ancient eruptions have been blamed for major world events such as the fall of the Chinese Xia dynasty, the disappearance of the Minoan civilization, and even a genetic bottleneck in human evolution that may have resulted from all but a few thousand human beings being wiped out 70,000 years ago. One of the most dangerous types of supervolcano is an explosive caldera, formed when a volcanic mountain collapses after an eruption so large that the now empty magma chamber can no longer support its weight. But though the above-ground volcano is gone, the underground volcanic activity continues. With no method of release, magma and volcanic gases continue to accumulate and expand underground, building up pressure until a massive and violent explosion becomes inevitable. and one of the largest active volcanic calderas lies right under Yellowstone National Park. The last time it erupted 650,000 years ago, it covered much of North America in nearly 2 meters of ash and rock. Scientists are currently monitoring the world's active volcanoes, and procedures for predicting eruptions, conducting evacuations, and diverting lava flows have improved over the years. But the massive scale and global reach of a supervolcano means that for many people, there would be nowhere to run. Fortunately, the current data shows no evidence of such an eruption occurring in the next few thousand years. But the idea of a sudden and unavoidable civilization-destroying apocalypse caused by events half a globe away will remain a powerful and terrifying vision, less fictional than we would like to believe. The winds were withered in the stagnant air, and the clouds perished. Darkness had no need of aid from them. She was the universe.